Welcome back to the basic concept simplified. Today we look at what is physics. We are going to give a more specific definition of what is physics, and this is a branch of science which deals with the study of the physical quantities and how they are related to one another. What are physical quantities? These are quantities that can be observed, measured, and their size expressed as a number followed by a standard unit. A good example of the physical quantity is length. Let's say 20 meters. The size is given as figure 20 and the standard unit is given as a meter. So when you talk of 20 meter, it's 1 meter repeated 20 times. What are the relationships among the variables? Actually, a good definition of physics is the relationship among the variables, which can either be a law, a principle, a theory, an equation, or a formula. Majority of the relationship in physics are named after the personalities who formulate them, and a good example is the Newton's second law of motion. This law was formulated by Isaac Newton. His main physical quantity were inertia force, momentum, and time. And he came up with this relationship that a change in the inertia force is directly proportional to the change in momentum with time. For a constant mass, that is a mass that is not changing, change in momentum is given as a product of the constant mass multiplied by the change in velocity. So if we now substitute that into the relation, we get that change in the inertia force is directly proportional to the relationship between the numerator we have the mass multiplied by the change in velocity, and the denominator we have the change in time. The constant of proportionality is unity, that is 1, and therefore if we now make it into an equation, you have that a change in the inertia force is equals to mass times acceleration. F is equals to m multiplied by a. This is now the famous Newton's second law, and it relates the inertia force F with mass m and the resultant constant acceleration a. Force, mass, and acceleration are all physical quantities. They can be observed and their size measured and expressed in a given unit. A practical application of the Newton's second law is the calculation of gravitational force, which is equals to the mass multiplied by the gravitational strength. We now look at the applications of physics.